And here is our review video on converting between moles and volume. So we have our volume in liters most of the time. We have another constant, so kind of like we had Avogadro's number, 6.02 times 10 to the 23rd. We have another constant in this same list. Go down, down, down. Here, volume of an ideal gas at STP. So we're going to use this number, 22.4 liters per mole. So there's 22.4 liters in every 1 mole of an ideal gas. It's kind of a weird word for chemistry. Nothing is actually ideal, but we pretend like gases are ideal so that we can actually use this number. Really, it's an estimate. Lots of things happen in the real world that take us away from this number, but we're going to pretend for now like this is what happens. 22.4 liters in every 1 mole of a gas at STP. So this idea of STP, standard temperature and pressure, is right here. Standard temperature and pressure, STP. Standard temperature is 0 degrees Celsius. Standard pressure is 1 atmosphere of pressure. This is the pressure that Earth's atmosphere exerts at sea level. So that's STP, 22.4 liters per mole. So if I have 4.5 moles of argon gas, and I want to figure out what volume it has at STP, then we're going to go ahead and set up our railroad tracks. Start with our given 4.5 moles of argon gas. I want to convert my moles to liters. I have moles on top. I want to get rid of it, so I'm going to put moles on the bottom. I want to turn my moles into volume. I'm going to put liters on top because liter is a unit of volume. We know that there are 22.4 liters in every 1 mole. 22.4 liters in 1 mole of an ideal gas at STP. So we can cancel out moles on top and moles on bottom. Moles on top, moles on bottom cancels out. With our calculators, we're going to multiply across the top. 4.5 times 22.4 divided by everything on the bottom. It's 1. We can kind of ignore it. 4.5 moles times 22.4 liters divided by 1 mole is going to give us 100.8 liters. Sig figs, we need to keep 2, 1, 2. 1, 2, that 0 turns that 0 into a 0. If I do this, I only have 1 sig fig. If I put a decimal here, now I have 3 sig figs. If I put a decimal here, well, now I only have 10. That's totally the wrong number. The only way to really write 100 with 2 sig figs is to put it into scientific notation. So we can call 100 liters 1.0 times 10 to the 2. I've got 2 sig figs. 1.0 times 10 to the 2 liters would be our best answer since I've got my 2 sig figs here. This one, I've got 2.0 liters at STP. How many moles of CO2 would it hold? So 2.0 liters is my given. That's what I'm going to start with on my railroad tracks. I have liters on top. I want liters to go away. I want to convert my liters into moles. Liters on top, liters on bottom, so that the liters cancel out. I want to convert my liters to moles. I'm going to put moles on top. We know that there's 22.4 liters 22.4 liters in 1 mole of a gas at STP. So now I can cancel out liters on top and bottom. We're left with moles, which is good because that's what my question is asking for. Multiply across the top, divide across the bottom, and we get 2 times 1 divided by 22.4. 0.08928. Lots of decimal places. My label is going to be moles since I crossed out my liters. I have 2 sig figs here in my given, so I'm going to keep 2. Remember that leading 0 is not significant. It's just a placeholder. So my 8 and my 9 are my 2 sig figs. This 2 is going to round that 9. It's going to stay a 9. And so my final answer is just about 0.089 moles of CO2. Go ahead and take a couple minutes, pause the video, do these 2 problems, restart the video, and check your work. All right, hopefully you have some answers and you're ready to check. So we're going to start with that given 0.032 moles of oxygen gas. How many liters, what volume at STP? Moles on top, we're going to put moles on bottom to get them to cancel out. I want to convert to volume. Volume is liters. I'm going to put liters on top. We know that there's 22.4 liters in 1 mole because handy dandy periodic table tells us so. My moles on top and my moles on bottom are going to cancel each other out. Moles on top, moles on bottom cancel out. We're left with liters. We're going to multiply by everything on the top, divide by everything on the bottom. 0.032 times 22.4. 0.032 times 22.4 divided by 1 is going to give us 0.7168. I have 2 sig figs, 2 sig figs. That 6 turns that 1 into a 2. Oops, liters, not moles, liters. 0.72 liters of oxygen gas. What if I have a 25-liter tank with helium gas at STP? How many moles is that equal to? We're going to start with our given. Our given is 25 liters. 25 liters of helium gas. We're going to convert those liters to moles. What do we know about liters and moles? We know that there are 22.4 liters in 1 mole. Is this going to work, my friends? No, I've got 2 liters on the top. That's backwards. So we need to flip our liters and our moles. Remember that we always want to get things to cancel out. If I have liters on top, I need to put liters on the bottom to get them to cancel out. 1 mole on the top. Liters on top and bottom are going to cancel out. Liters and liters cancel out. We're left with moles, which is good because that's what we want to find. We're going to multiply across the top, divide along the bottom. 25 times 1 divided by 22.4. 25 times 1 divided by 22.4 is going to give us 1.11607 oodles of decimal places. I have 2 sig figs in my given. I'm going to keep 1, 2. That 1 is going to leave that 1 a 1. So our final answer is just about 1.1 moles.